In this video, I'm going to explain how to do the derivatives from a graph and a numerical approach. From the graph, it depends on the AP test. You guys are getting two different type of questions. For example, I'm going to explain it first before I go there. For example, if I have the graph of this, that's a parabola, and my graph is this is my original graph, f of x. Then I have another graph which look like this, and it's going through here. This is my f prime x. So that's my original graph, that's my derivative. If the question is asking find where the f prime x, find f prime x is positive. Now, you guys can tell the graph is given as f of x. How in the world I can get the slope for this graph? Since we already know from pre-calculus to algebra 2 classes, we know the linear slope. Like this is my linear graph, and the slope is rise over run, or y2 minus y1, x2 minus x1. This is how we find the slope of the linear function, like y equal mx plus b. But this is a parabola. How do I find the slopes, like f prime, which means a derivative, which means a slope, for this parabola? You have to draw a tangent lines. Have to draw tangent lines. Tangent lines. Okay, so I'm going to draw a tangent line here. Up here, you can randomly pick some points and draw tangent lines. So these are my points. This is a positive, positive, that's a 0, negative, negative, negative. All of these tangent line slope is negative. This one is 0. All of these tangent line slope is positive. So if I'm asking find f prime, like where my slope, actually this means slope, where my slope is positive, then I can say from 0 to positive infinity. And you always give them intervals. They ask you for the intervals. So I'm starting with 0, and this one is going infinity, positive, because I'm giving them intervals, the x values, not the y values. So that's where it goes. If they give you f prime x and they're asking find where or at which intervals my f of x is increasing or maybe decreasing, okay? So where it increasing, since this is f prime slope, so every y value is actually my slope, right? So how do I say that? Where it's increasing, above x-axis and below x-axis. So this one is gonna go for above x-axis and below x-axis. So the above x-axis is this portion. This portion is above x-axis, this one. So 0 to positive infinity, I'm going positive, I'm increasing. From 0 to negative infinity, I'm decreasing. So this is how it's going to go. Okay, let's try this. So far, our understanding of the derivative is that it represents the slope of the tangent line. I already told you derivative means slope of the tangent line. Like slope of these small tangent lines, the one I drew up here. Complete the table below. Estimating. We're gonna estimate, like we are going. If you see the word estimating for f prime x, then it means you are looking for a secant slope. What is secant slope? Secant slope means f of b minus f of a over b minus a. And technically, f of b minus f of a is just is a fancy version of y2 minus y1 x2 minus x1, y2 minus y1 over x2 minus x1. Okay, at the indicated x values by drawing a tangent line, estimating its slope. So we're going to draw a tangent line at the point at the x value they are telling me, and also I'm going to estimate the slope. So let's try this one. The first one, estimation of the derivative, which means I'm looking for f prime negative 7. Approximate. So where is the negative 7? 1, 2, 3, 4, 5, 6, 7. That's negative 7, which means my dot at negative 7 is this. If I draw a tangent line at negative 7, technically I should be getting a line. I'm not going to go straight line, but it should look like this. So my slope at this is at this tangent, at this x value, and for the tangent line I can say I'm going to go 1, 2, 3, 4 and 1. You see this? I'm rising 1, 2, 3 and 4 and 1. So technically my slope is 4. I'm estimating. On the AP test, technically they literally give you the points to find the secant slope. But in this case, I'm just estimating. I'm drawing a straight as much straight as I can, line, tangent line, and I'm giving them the answer. So is the function increasing, decreasing, or at relative maximum or relative minimum? Is the function increasing? If the slope, this tangent line slope is positive, then yes, it's increasing. This is what I was talking about up here. When it's positive, all the positive slopes is increasing. Equation of the tangent line at this value of x. Equation of the tangent line is going to be, first I have to find, this is equation of the tangent line, right? This. So I have to look for x, I already have it. Slope, I already have it. Now I have to find the y value at negative 7. This is negative 7. The y value is 1, 2, 3, negative 3. So my y value is negative 3, which will turn positive. Slope is 4, and x minus negative 7 will make it positive, and that's 7. That's my equation. Let's find f prime negative 6, approximation. So where is negative 6? I'm going to draw negative 6. 1, 2, 3, 4, 5, 6. My tangent line at negative 6 is, like for example, it's going to go like this, and then it goes like this. So if I pick this point, I'm 1, 2 rising and 1 to the right. So my slope is 2 technically. If it's positive, I'm increasing. The increase and decrease would goes with the original graph. F prime would go f of x like greater than 0 and less than 0. Now how do I find the equation here? My y is going to stay y. What is the y value at negative 6? Negative 6 y value is technically 0. So I'm going to say 0. What is my slope? 2 and x positive 6, because negative 6 and minus sign turn positive. So this is my equation for this one. Let's try f prime negative 4, approximation. And this is actually technically approximation. If you have a ruler, you can draw tangent line straight, and you can definitely find your rise and run or follow front. So here you go. We have negative 4. So 1, 2, 3, 4. Negative 4 slope is technically 0. So I can tell that one, this is 0. So if it's 0, when the derivative is 0 at some point, which means we have a relative maximum and minimum. So you can tell this is my relative maximum. It's the top relative maximum. My equation, it's going to go y. Now, what is the point at negative 4? It's 2 positive right there. So it's going to go minus 2 equal, the slope is 0. X minus and negative 4 turn positive. There you go. So technically, when I do this, it's going to be y equal 2. Now I do f prime negative 2 approximation. Negative 2. Draw negative 2. 1 and 2, this is negative 2, and I draw a tangent line, and technically this tangent line is giving me a negative slope. So I'm falling 1 and running 1. Do you see? I'm falling 1 and running 1. Like I'm picking exactly these corners where my line is going. So it's negative 1 approximation. If it's negative 1, it's negative. The slope at -2, the slope of the tangent line at -2 is -1, which means it's decreasing. My equation, what is the y value at -2? This is -2, the y value is +1. So I got 1 equal, the slope is -1x +2. Next, I got f prime -1 approximation, f prime -1 approximation. Here is -1, and if I draw a tangent line, it's negative, and then negative tangent line means 1, 2, and 1. So that's -2, like I'm falling 2 and running 1. So that's -2. It's decreasing still because this is negative. The slope of the tangent line is negative. Equation, what is the y value at -1? This is -1, the y value is -1. So -1 and -1 is going to turn positive. Slope is -2x +1. Then I have f prime 1 approximation. Where is f prime 1? This is 1 and the slope is 0. So this one is 0. And what do I have here? It's a relative minimum because that's the bottom of the hill or the valley. That's the top maximum. That's the top maximum. This is the valley hill, which is relative minimum. My formula y, what is my y value at 1? My y value at 1 is -4. -4 and minus turn positive. Slope is 0, and I x plus x minus actually 1. F prime 3 approximation. Let's see 3. This is my 3, and I have draw a tangent line, like draw a tangent line that crosses this. So I'm rising 1, 2, and 3 and run 1. So the answer is 3 over 1. And it's increasing. And my equation is, what is the y value at 3? The y value at 3 is -1. So minus -1, which turn positive, equal, the slope is 3x minus 3. And 5 and 7 and so on. So I don't have to do that one. Okay, let's try this. Numerically, the value of the derivative at the point can be estimated by finding the slope of the secant line passing through 2 points on the graph on either side of the point for which the derivative is being estimated. Anytime when they use the word estimated derivative estimation, then it means I'm doing secant slope. What is secant slope? F of b minus f of a over b minus a. That's what secant slope is. Now they said estimation of derivative. Now we're going to use the secant slope because we have the points up here. Now 0, that's my 0. If I'm looking for a secant slope like 2 y values and the x values and stuff like that, then it means I have to I think I skipped that one. So let me do this one. Based on what you observed in the table on the previous page, what inferences can you make about the value of derivative f prime x and the behavior of the graph of the function f of x? Remember always, f of x function always deal with increase decrease words. F prime, you can say greater than 0 or less than 0. These are the things. So let me write it down. For my first one is, if f prime a is greater than 0, then the graph of f of x is increasing. At x equal a. Next, if f prime a is less than 0, then the graph of f of x is decreasing. If the slope we get negative, then it's decreasing at x equal a. Second, third, f of x has a relative maximum if f prime a is equal 0 and f prime x changes signs from positive to negative. Next one, last one, f of x has a relative minimum if f prime a is equal 0 and f prime x changes signs from negative to positive. Done. Okay, let's do this. Now in this case, they said find the derivative estimation at x equals 0. Now at x equals 0, or if I'm looking for estimation, make sure that you understand that I have to pick this is a 0. I'm not going to pick 0 and 1. I'm going to pick the one close to them. So I'm going to pick this and I'm going to pick this. This is my x1. This is my y1. That's my x2. That's my y2. But like I said, you know we are going to use f of b minus f of a. So y2 is my -3 minus 2, y1. x2 is 1 minus -3. So my answer is -5 over 4. And that's the estimation. Done. Is the function increasing? Is the function increasing? No, it's decreasing because you know my slope is negative. Equation of the tangent line. Again, y minus, what is the y value at 0? Y value at 0 is 1. The slope we got -5 over 4. X minus, what is my x? 0. Done. Okay. Try another one. 1. This is my 1. So if this is 1, for 1, I'm going to pick arbitrarily close for 0 and 0, 1. You're going to pick left and right close to this number, not exactly that number. So if I'm looking for f prime 1 approximation, I would say again, for example, this is my y2, which is 0 minus 1, and x2 is 4 minus 0, which will give me 1/4. So -1/4 actually approximation, negative sign with this 1. So -1/4. Is it decreasing? Yeah, because it's negative. Equation y minus, do I have a y value at x equal 1? Yes, it's -3. So if I do -3, they turn positive. Equal, the slope is -1/4 x minus 1, the x value. Let's try another one. 4. So this is 4, right? So you're going to pick arbitrarily close to 4, 6, -7, and 1 in -3. So let's try f prime 4 approximation, -7 minus -3, which turn positive. Then I have 6 minus 1. So 7, 6, 5, -4 over 7. -4 over 6, subtract 1, I'm sorry, not 7, 5. So that's my approximation. It's decreasing again. And my equation is y, what is the y value at x equal 4? It's 0. So -0, the slope is -4, 5. And I have x minus 4. Done. Last one, f prime 6 approximation. So if it's 6, this is my 6. The closest is 10 over 2 and 4, 0. 10, 2 and 4, 0. So I'm going to pick 2 minus 0 and 10 minus 4. Make sure which, if in the bottom, on the top, this number is the first one and that's the second one, then make sure the same x value goes first and the other one second. So 2 over 6, which will give me approximately 1/3. This one is actually increasing because it's positive. Y minus, what is a 6 y value? It's -7. So I got -7, which turned positive. The slope is 1/3, x minus 6 as an x value. That's done. Okay, the graph of the function g of x is pictured to the right. This is g of x function, which means that's my original function. So I'm going to mark this already, g of x original. Is pictured to the right. Identify the following characteristic about the graph of g prime. The question is asking about the g prime axis. This is what they are asking. So always make sure that since gx is given and they are asking for a slope of this graph, then of course I have to draw a tangent lines. Just every time write it down on a paper like this. The intervals where g prime axis is less than 0, which means where my slope is negative. I'm going to draw a tangent line and I don't know which one is negative. 1, 2, 3, 4. These tangent lines are all of them positive, 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 positive. And then I'm going to draw a tangent line over here, and they are all negatives. If I draw tangent lines here, then all the tangent lines are positive. If I draw a tangent line here, it's negative, 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 negative. All of them are negative. Okay, so this one, they say g prime is less than 0. The negatives are the yellow one and the pink one. These are the only tangent lines that are negative. So I'm going to say, you're going to say this, g prime, pick every word from the question right now. So it says g prime x is less than 0 on -4 till -2. -4 and -2. Then another one that I have is the pink one. So the pink one is going 1 through positive infinity, because I'm not going to say negative infinity because I'm not talking about a y value. I'm talking about x intervals like a y value, x value. So this x value is positive. So going in this direction is a positive infinity. Okay. Then it says, because, why? Because the graph, because gx graph is decreasing. I have to use the word decrease and increase when I'm talking about the original function gx. And after because, whatever comes after because, it's whatever is given. Okay, let's try this one. The interval where g prime x is greater than 0, which means all my values are positive. So I can see the values are, the slopes of the tangent lines are positive from negative infinity to -4. So I'm going to say g prime x is greater than 0 on negative infinity to -4. Then another one is this, which is -2 from here to all the way to 1. Because g of x graph is increasing. Okay, the value of x with g prime is 0. G prime 0 means the slope is 0, right? So that means horizontal. I have slope 0 here, I have slope 0 here, I have a slope 0 here. So you're going to say g prime x is equal 0 on x equal -4, -2, and 1. Because g of x, because g of x has a relative maximum or relative minimum. So remember that when g prime x is equal 0, then it means you have a relative max or relative min. Relative max or relative min. Okay, definition of the normal line. Let's do that one. This one says, picture to the right is the graph of this. Draw the tangent line to the graph at x equal 1. This is 1, that's a tangent line. Then estimate the value f prime 1. So I have to draw a tangent line before I answer everything. So you know my slope is technically going negative. So negative means I fall down 1, 2, -2, and I'm done with that one. It's supposed to go like right here. So I will approximate that f prime 1 is approximation is -2. Equation is y minus, what is the value? Y at x equal 1, which is 2. Slope is -2. X minus, what is the x value? It's 1. So it's done. The normal line is the line that is perpendicular. Make sure you remember this. Normal line is always perpendicular to the tangent line at the point of tangency. Draw this line to find the equation of the normal line. So I'm going to draw this line up here at the point of tangency, like this. So do you see I'm making a 90-degree angle? It's a perpendicular, and also it's perpendicular to the other line. Now when the lines, and they said find the equation of the normal line. Normal line means perpendicular to the tangent line, which means opposite signs and reciprocal. So if my slope in here is -2, I have to make sure that I change this to y equal mx plus b first, or I don't have to, because they are only asking equation of the normal line. So normal line equation is going to be everything the same except the slope. The slope is -2. So if I'm making a normal line slope, then it means it's going to be reciprocal. For example, this one has a 1. And the sign is going to change to positive, and it's 1/2 x minus 1. So these slopes are reciprocal and opposite sign where the normal line is. The graph of the derivative h prime x of the function hx is pictured below. This is h prime x. When you mark this h prime x, then make sure that you write with it y is a slope. Every y value is a slope. Identify the characteristic of hx. Give a reason for your responses. And also h prime x, when the question is asking about f function, then it means I have to do above x-axis and below x-axis, above and below x-axis. So let's try. The intervals where hx is increasing. This is my h prime technically. So which means every y value is my slope. If the y values or if the slopes are positive, then I would say the hx is increasing. So where my slopes are positive? My slopes are positive. My slopes are positive at -2 to 1 and 3 to positive infinity. So I'm going to say h of x is increasing. I'm picking stuff from the question. H of x is increasing on the intervals -2 to 1 and then 3 to positive infinity, because h prime x is greater than 0. So that's the answer. Next, where it's decreasing. So I'm going to pick the question. hx is decreasing on which intervals? Decreasing means all the y values is going to, since this is h prime, I have to look for the y values. If it was original, I would look for tangent lines. But this is h prime, so I'm looking y value from 1 to 3. 1 to 3, they are decreasing because h prime x is less than 0. The values of x where hx has a relative maximum. Now, what is relative maximum means? When you go to positive to negative, right? Look at the graph. the positive to negative, what is going positive to negative, which means the slopes of tangent lines are going positive to negative. In this case, slope of tangent lines, I don't have a tangent lines, but I do know the slopes are at every y value. So where my y values is going from positive to negative. Now look at this. This is the only point at x equal 1 where my graph is going from positive to negative. So I'm going to say relative maximum. I can say each x has a relative maximum at x equal 1 because h prime x changes signs from positive to negative. The next one says what value of each x has a relative minimum, which means negative to positive. So you're going to go up there and check where my graph is going from negative to positive. My graph is going from negative to positive here. My graph is going negative to positive is here at 3. So negative 2 and 3. So again, I'm going to pick the words from the question. Each x has a relative minimum at x equal negative 2 and 3 because h prime x changes signs from negative to positive. If h negative 1 is half, what is the equation of the tangent drawn to the graph of each of x at x equal negative 1? Now, if you guys pay attention, they said draw a tangent line at x equal negative 1. The slope, my m is 5. I already know that. So I'm going to say y minus half, because that's the y value, equal the slope is 5, x minus negative 1, which turned positive. That's my equation. h2 is negative 3. What is the equation of the graph? So if you look at it, I need y minus y1. y1 is going to be negative 3, so it turned positive. What is my slope here? At x equal 2. So here is x equal 2 and my slope is negative 2. So I'm going to write negative 2 x minus x1 is a 2. So done. So if you guys have any questions, again, please let me know. I will explain it further or give you more examples. Please like, subscribe my channel. Thank you so much.